All right, a little bit more, getting into more details here. Let's say you have a vehicle going at a speed of, before we consider the speed, what you see in this diagram over here is basically the same forces, the same type of forces that we had before. It's just another designation for the different types of forces. So R sub A is the aerodynamic resistance, again, from the acting from the wind on the vehicle front face. The weight of the vehicle from the gravity can be broken down into two components, the vertical components, not the vertical, the component perpendicular to the surface, and the components which is horizontal and parallel to the surface. And then, of course, there is a friction between the tires and the road surface, and based on the type of the road, let's say if you're driving on a concrete pavement surface, the friction between the tire and concrete pavement surface is going to be different compared to when you're driving on an asphalt road. And then there's a rolling resistance based on the type of the grade, or we call that or R sub RL, and that depends on how deep or how steep is the grade when you are climbing or when you're going downhill. Okay, so there is the rolling resistance is actually a result of interaction between tire and road surface that we already mentioned that. And again, a lot of factors affecting that problem or that factor. We mentioned about the pavement type, surface type. The tire pressure is very important, and the tire deformation on the road surface is also very important. That's why a lot of tire companies or tire manufacturers, they are investing a lot of resources in designing the optimal shape of the tire threads or the optimal shape of the tire surface to minimize the fuel consumption and actually adapt the type of tire for the climate condition and the type of road that you're driving on. So the rolling resistance can be, we can categorize the rolling resistance, and we can say that it's depending on the vehicle speed, the tire pressure, the temperature is very important, and also the rigidity and flexibility or flexibility of the tire and pavement. And of course, it's a function of friction, and also as you remember, we talked about that the component of the weight. We can break it down to two components, one parallel to the surface and one perpendicular to the surface. And the one normal to the surface or perpendicular to the surface, that's the one that is affecting the rolling resistance. Okay? So if you want to formalize that or put it in an equation format, the rolling resistance can be a function of friction times weight. And this is actually W times cosine of theta. Theta is the degree of the slope. And if you remember from basic calculus or algebra, if this angle is theta, so is this one. So this one is also theta. We can call it theta sub g or just theta. And then if this is the actual weight of the vehicle, if you want to convert it to the normal component of the weight, we just multiply weight by the cosine of theta. And then the other component will be W times sine of theta, right? So W times cosine of theta, and then we also said that it's a function of friction, so that's going to be friction times the normal component of the weight. But let's have a quick assignment here. It's not an assignment, it's basically a class activity or practice type of activity. Let's pause for a few seconds. I'm going to pause for a few seconds, and I would like you to calculate